Imagine a battlefield where swarms of drones attack simultaneously, moving rapidly and unpredictably. For human operators, targeting and neutralizing each drone with precision becomes an overwhelming challenge. However, the US Navy is pushing the boundaries of technology to overcome this problem. Through a collaboration led by the Naval Postgraduate School, NPS, a new AI-powered tracking system is being developed to make laser weapons smarter and faster, capable of handling multiple drone attacks autonomously. Laser weapons, known for their ability to strike at the speed of light, are being seriously developed by major military powers to counter modern threats. However, these systems are not perfect. One of the biggest challenges lies in identifying the target's weak spots and maintaining the laser beam precisely on those spots long enough to disable or destroy the drone. While human operators can manage single targets, the situation becomes much more complex with swarms of drones. The speed and unpredictability of autonomous drones further complicate the task, making manual tracking almost impossible during intense combat situations. The solution lies in artificial intelligence. In a joint effort involving the Naval Surface, Warfare Center Dahlgren Division, Lockheed Martin, Boeing, and the Air Force Research Laboratory, AFRL, an advanced AI system is being trained to handle these challenges. To achieve this, the team created a miniature model of a Reaper drone, 3D printed from titanium alloy. This model was scanned using infrared and radar technology to simulate how a full-size drone would appear through a telescope under various visibility conditions and angles. Using this data, 2 datasets of 100,000 images were generated to train the AI. The system learned to identify the drone, determine its angle relative to the observer, locate its weak spots, and hold the laser beam on those points. Additionally, radar data provided real-time information about the drone's position and trajectory. The training involved 3 phases, one using only synthetic data, another combining synthetic and real-world data, and a final phase using only real-world data. According to the US Navy, the third approach yielded the most accurate results. This advanced AI tracking system aims to reduce human intervention while increasing precision and efficiency. In practice, the AI can process vast amounts of data and make split-second decisions that a human operator could not manage under high-pressure situations. As the technology progresses, the Navy plans to conduct field tests with real targets using a semi-autonomous system where human operators will still oversee certain aspects of the process. Eric Montag, an imaging scientist at Dahlgren, shared exciting developments. We now have the model running in real time inside of our tracking system. This year, we plan to demonstrate the automatic aim point selection within the tracking framework as a proof of concept. This innovation represents a significant step toward enhancing national security, as it allows laser weapons to respond rapidly and accurately to emerging drone threats. With continuous advancements, the US Navy is preparing for a future where AI-driven defense systems will play a crucial role in safeguarding military operations.